A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. Good afternoon. So, hello, good afternoon to all of you, and welcome to the session after the break. I hope that you guys are refreshed enough, and I hope you guys are attentive enough. I hope the lunch has not been so heavy to put you in a kind of a slumber, because now we are going to cover something which is very important, very relevant, not only for your examination, but the general understanding of what actually happens and how is it that India gets impacted in terms of its climatic phenomena, in terms of its climatic conditions. But before that, we shall be finalizing upon certain areas in jet streams, that how is it that the jet streams end up influencing the weather conditions. Now, when we talk about these particular jet streams, we have seen that these jet streams, why they are created, the formation of it is something that we have understood. We have also understood that these jet streams, they end up taking a kind of a wavy path, in the sense that they have a horizontal as well as a vertical meandering, that in certain areas they rise up, they fall down, again they rise up, they fall down. We have also seen that in areas, for example, in this region, that is the Himalayas, the jet streams are not present. And we have seen that the subtropical westerly jet, they get deviated into the northern and the southern branch owing to the physical barrier, right? And Priya, those winds which are diverging from Himalayan range, isn't it creating leeward dry air and make a different jet stream pattern? No, the jet stream does not go into that area itself. Because of the obstruction faced by the mountains, that is the Himalayas, the jet streams won't even enter into that area, right? So that is when they will end up diverging into two parts. So if the jet streams would have come to this area, then that leeward side impact would have been observed, but they are straight away going on the sides of it. I hope that is understood, Priya. Shiva, you have a much more contemporary question. In today's India versus New Zealand, India in Dharmshala, India chose to bowl on considering the dew factor, but it was cloudy. Have India predicted wrongly? See, the occurrence of dews, particularly when you talk about Dharmshala. Now, Dharmshala is situated at a particular altitude, at a height. So there, the temperatures at night, they will dip down quite significantly. So that is why dew formation in the mountains is not always restricted only in the absolute clear conditions. So yes, the cloudy factors will always be in influence, but in higher up, in lower temperature regions, dew formation can be observed. Priya, does it because of height of of the Himalayan range mountains? Yes, that is true. So it is because of the height of the Himalayas, where the average height, if you consider the region around Hindu Kush, around the western portion of the Himalayas, the average height is around 6 kilometers to 7 kilometers above the surface. Now that interferes in the movement of these jet streams, the existence of these jet streams in totality. That is why the jet streams are absent in that area, and that is why they have a distinct northern and the southern branch. Okay. Gaurav, is we had started Indian geography? No. We will cover oceanography before that, but why we are going to cover Indian monsoon and Indian climate before that is because as long as we are in the portion of climatology, you will be able to correlate with it. I understand that once we are done with the portion of climatology, in your memory also, it will be done and dusted. And when we will cover the monsoon, maybe at the time of Indian geography, it will be a kind of a situation where you will require a revision of the earlier portions as well. So I am not going to take that risk. Immediately, as the concept of climatology is fresh, immediately we are going to target the portion of Indian monsoon so that you can have a correlation. Okay. So now we basically talk about the jet streams and the impact that they have on the weather. So, first of all, jet streams, because they are very fast moving bands of air, these jet streams, they have the ability sometimes to carry certain disturbances over long range, over a long distance, right? In the sense that, let's suppose you have these jet streams in this area. Shashank, when books are provided. Shashank, my dear friend, as you would already be aware that there are certain issues going with the books and the provision of the books in terms of the supply, the logistics part of it. And I'm sure the mentors would be assisting you in that. But that is why what I would suggest to you rather is, don't let this particular hiccup influence your preparation. That is something that I suggest all of them and all the students who are asking this question. Please don't let this temporary hiccup impact your overall preparation. What I would want you, or what I would rather suggest you, is please do start reading from the PPTs itself. The tablet that you have, the PPTs that you have, is more than sufficient. And for geography, anyways, the best book that you can refer, or the book that you can refer for GS, is NCRT, which is available online as well. So take the help of that while we are trying to resolve this particular issue at our end to the best possible way. But there are certain issues which have indeed cropped up, and we are, trust me, we are at every possible level trying to get it resolved. Okay. So I hope you stick to your larger goal, that is clearing the examination. How do you clear the examination? You stick to that. We will take care of this end. Okay. Now, having said that, see, and one other thing I would like to tell you, see, any areas where you feel that because you have initiated the preparation, any of the regions where you feel that your preparation is not going as per plan, where you do need certain help, you need certain feedback, I hope you have my mail ID. And if you ask the previous candidates and the students as well, we continue to remain in touch even after maybe your course ends, or even after, let's suppose, first or the second attempt doesn't go particularly well. So please do feel free to reach out. Okay. Any issue that you face, to my level best, I will utilize all my experience to help you out of any precarious situation which is there. The end goal for you and for me is the same. That is, I want you to clear the examination. You are there to clear this examination. So let us, both of us, work towards that, and let us try to achieve that goal in plain, simple language. Okay. Priyas, even after these sessions, do we need to go for NCRT books? Just as a point of revision, just so that you have that point of reference that I have covered the book as well, that will give you some self confidence. I will give you, maybe next weekend, I will provide you with a methodology about how the revision for geography needs to be carried out. But till that point of time, stick to the class PPTs, the annotations of the PPTs, and eventually, after you have done a couple of revisions, then pick up the NCRTs. Once you are thorough in the class, as most of you have been, trust me, covering the entire NCRT geography for 11th and 12th won't take you more than 7 to 8 days. Okay, so that is all that you need to put in, and that will give you the prelims and mains examination is all about confidence. I have seen candidates who are so well informed, they bungle it up in the prelims examination because of lack of confidence. And I have also seen candidates for whom all of us were certain that this person doesn't have enough knowledge to clear the exam, but because they were confident enough, they applied their logic and they did clear the prelims at least. So for that confidence building, you can go through the, if let's suppose not NCRT, take the help of the tablet lectures. That is also more than sufficient. But as a point of reference. Okay. Now, here, after that, let us continue with the portion of how is it that the jet streams will end up impacting the weather. How is it that the weather phenomena are influenced? So, when we talk about this, these jet streams, they are very high altitude winds, right? So let's suppose in a particular area, in a particular region, let's suppose you have these jet streams in existence. Okay. And if suppose here you have a condition of a cloud cover, right, or a low pressure disturbance which is there, low pressure disturbance. Now that low pressure and the entire disturbance can also be carried with the help of the jet stream. The cloud cover can be carried by the jet stream. So as you can see in this image as well, ideally the cloud is not present in this area. Ideally the cloud is present in this region. But then this cloud can be very easily carried over and rainfall will be received in this region. Why? Because of the impact of jet stream. So jet stream is able to, or these jet streams are able to carry these weather phenomena across very, very large distances. Okay. Now, one other factor that you need to be very well aware about the jet streams, they never allow the mixing of air from the close vicinities. What do I mean by that? So, when we talk about jet streams and weather, so the jets do not allow for mixing of air on the ground surface. Now, what do we mean by this? What is the implication of this? So let's suppose I will show you the cross-sectional analysis. So let's suppose this is the ground surface. Here you have a jet stream in cross-sectional view. Okay. Jets. Now you have to understand that when we talk about this jet stream, it is not a local phenomena that we are talking about, that over Indore the jet stream is there, but over Bhopal jet stream is not there. Over Hyderabad jet stream is there, but over Vijayawada jet stream is not there. It is not a very regional phenomena. Jet streams can continue for a distance of thousands of kilometers at one stretch. As you can look at by this image as well, that the jet streams can be a continuous phenomena. So maybe there is a distortion here, but does not mean that the entire jet streams will be impacted by this. So what this means is that in this region, this is the region where the jet stream is moving. Now, here, the jet streams can be at a height of, let's suppose, 7 kilometers or 8 kilometers from the ground surface. Let's assume. This is an assumption. Now, that means they will have an influence on the air pattern immediately below it as well. The air column in the region is impacted. Its place by the jets. Now suppose here you have warm air in this area. Let's suppose in this region you have a warm air. Let's assume here you have cold air. Everything is happening in the region of troposphere. Okay, it is happening very much within the troposphere. Okay. Now, ideally, what happens? Ideally, under normal conditions, let's suppose in this area of warm air, or in this region where there is significant amount of heating, let's suppose the ground in this region has gotten heated up significantly. So there will be development of low pressure. Under normal and ideal conditions, what would have happened is that this wind would have moved, colder air would have moved into the area of the warmer region, and it would have moderated the temperature. We have seen that wherever there is low pressure, from the nearby colder areas, they come in and they basically provide that wind in that region, provide that air in that region, normalizing the pressure in that area, right? We are comfortable with that. But here, the cold air won't be able to reach that. Why? Because here, the cold air will be facing almost a kind of a wall in this area where the jets are in existence. And because the cold air faces that kind of a wall, so that means the region of the warm air keeps on or goes on being isolated from the region of the cold air. So in this area, many of the times it also happens. So for example, the jet stream, that jet stream can be very, very broad, can be very, very wide as well. Okay. So it can happen, as has happened in the region of Canada and Siberia recently in the past couple of years, that if this region gets heated up, the air, when it is rising up due to that heat, that air is not able to rise beyond a certain point, is pushed back by these jet streams on the ground, further leading to the heating process. You would have experienced that basically in the region of Canada, in the region of Siberia, even in Europe for that matter, for the past couple of years, they have been experiencing heat waves, right? Unprecedented heat waves, where for those countries, unprecedented heat waves mean the temperature of around 35 or 40 degrees, 45 degrees Celsius. In India, we call it summer season, but there it is an unprecedented heat wave where the public infrastructure starts melting all of a sudden. So, why does that happen? That is because there is that particular jet stream which simply rebounds that heat, does not allow the air to mix. Now, that leads to subsequent weather pattern changes as well. For example, ideally, this region would have gotten heated up, would have basically experienced a low pressure condition, and you would have the condition where the cold air would have come in and the conditions would have normalized, the temperature would have been normalized. But now, in this situation, there is no such cold wind which is going to come over. There is no such cold wind which is going to interfere. So the warmer region keeps on getting hotter and the temperature continues to increase further. So that also means that the warmer areas, their heating gets exaggerated. The regions which are receiving rainfall, the rainfall would be restricted only into that area. It won't spread over. Okay. So that is basically the impact or the role of jet stream in terms of the weather phenomena. As I told you, for the past few years, the region of Canada has been experiencing this, what is referred to as the heat dome phenomena, where you would observe that if this is the ground surface, these are the jet streams. Even after getting heated up, the air, if it rises up, immediately it is pushed down by these jet streams, right? So it further, while sinking down, it will further get compressed, further heat up, further rise up, again getting pushed down. So that is why these regions experience sudden and significant surge in the temperature that they experience. Okay, I hope that is understood. Is it any kind of a front? No. Generally, the jet streams, they do exist in the region around fronts, but even if there is no front, they won't allow the mixing of air. For example, as long as these I will talk about it in greater detail in next module, but you would be interested to know that as long as the southern branch of the jet streams are in presence, they won't allow the onset of monsoons in India. Onset of monsoon never happens in India as long as the southern branch of jet stream is in place. Only when that jet stream disappears will the southern branch come over. Okay, so that is where they prevent the mixing of air, they prevent the coming of the air in that area. Okay, now, so the fast moving wind patterns or currents in a jet stream can transport weather systems across the world, affecting temperature and precipitation. And they play a key role in determining the weather because they usually separate colder and warmer air, don't allow them to mix together. allow mixing of air. So that means the hotter regions or the warmer regions continue to get hotter without any relief. This is the reason for extraordinary heat waves present or experienced in recent years in Canada, Siberia, and parts of UK. That is something which you will observe as a common factor for all these jet streams. Okay. Now, let us take the question which was asked in 2020 prelims. This also represents the changing pattern in which UPSC is basically trying to mix and match various concepts and then frame a question for you. So let us take a look at this question. Consider the following statements. Jet streams occur in northern hemisphere only. Only some cyclones develop an eye. The temperature inside the eye of the cyclone is nearly 10 degrees Celsius lesser than the surroundings. Which of the statements are correct? Is or are correct? I think 30 seconds would suffice for this. Correct, Usma. Satyanarayan, beautiful. Good, Shahid. Shahid and Usma, you have been getting almost all the questions correct since yesterday itself, which is good, encouraging. Madhuri, incorrect. So again, UPSC has managed to trick you in terms of its framing. This is so all those who have marked B, you have fallen for the trap that UPSC had laid in this question, and basically that is the trap that UPSC lays down. So let me tell you what is the trap. First statement: jet streams occur in northern hemisphere only. Incorrect. Only some cyclones develop an eye. Absolutely correct. You will have tropical cyclones which will always develop an eye. Some temperate cyclones will have an eye, but many of them don't have an eye. So this is absolutely correct. Then the temperature inside the eye of the cyclone is nearly 10 degrees Celsius lesser than the surroundings. So when we talk about the eye of the cyclone is the place where all the latent heat is accumulated. Eye of the cyclone is the place where you have the sinking air column. Eye of the cyclone is the place where you don't have cloud, you have clear sky. Isn't it? So that means eye of the cyclone is actually warmer than the eye wall and the surroundings. Right? So why this is incorrect? Because eye is warmer than the surroundings. Now, what is the trap that UPSC laid here? UPSC had put forward this figure. If UPSC had straightforward put a question or a statement that the temperature in the eye of the cyclone is less than the surrounding, you would have applied your mind that is it less or is it more? But the moment UPSC puts this, it is 10 degrees Celsius lesser, that tricks the mind to think that is it 10 degrees Celsius lesser, or is it 8 degrees Celsius lesser, or is it in that 15 degrees Celsius lesser. So your all the attention and concentration is laid on the data pointer here, and that is what UPSC wants you to do, that pay attention on the data pointer, so that the larger purpose of the statement is something that you are denied of in terms of its visibility. Okay, so this is one of the tricks and arsenals in its sleeve. You will observe this being played out in different subjects. It plays with the data pointers. It will put or throw some data pointer to throw you out of your comfort zone, so that your mind starts thinking in a way that, oh my God, I did not study this. Was it 8 degrees Celsius? Was it present in the notes? Was it present in the lecture? It is not there for consideration at all. Okay, so 3 is incorrect, and the correct answer is C, that is 2 only. Is that understood? Please be on the lookout for these particular things and these particular traps going ahead. Now, after this, I was thinking less or more only, not on data. Yeah. So in case you are thinking on less or more, that is still okay. But majority of them, they committed mistake in this particular year in 2020 because of the fact that they thought about 10 degrees C or 8 degrees C. I still remember or recall that when we had the prelims paper discussion after this, a lot of candidates got in touch that was it 10 degrees C or 15 degrees C? How do we get to know what kind of factual question is this? So that means the attention has been diverted, right? So that is something that please keep in mind. Otherwise, you're in a good place. So now we come to the portion of India's climate and India's monsoon season. Now, this is a particular area which becomes very relevant for both your prelims as well as for your mains examination. So when we talk about the prelims exam in this, basically, you will find areas such as monsoon phenomena, factors influencing the monsoon, then pre-monsoon showers, then rainfall distribution, then western disturbances. Okay. And for your mains examination, you get questions about factors influencing the monsoon, rainfall distribution, as well as western disturbances. Okay. So that is basically the portion of monsoon which is relevant for your examination here. When we talk about the Indian monsoon, it is one of those very rare phenomena, one of those very rare occurrences which are observed only in, to the truest extent, in India. Okay, it does shape the way of life in our country. It does shape the customs, the traditions in our country. Various parts of the country, you would observe that festivals and festivities and various traditions, they all follow very closely with the pattern of the rainfall as well. So monsoon has been a part of our life for a very long period of time, for thousands of years almost. And basically, in our country, almost 75% almost of rainfall is received only during these 3 to 4 months of monsoon. But when we talk about India in general, India experiences a variety of climatic conditions. When we talk about India, from north to south, from east to west, we experience the coldest of the conditions to the hottest of the deserts to significant high amount of rainfall in the region of Western Ghats, in the region of Meghalaya, to also a less than average or a drier condition in areas such as Telangana, Maharashtra, and so on. So we experience a variety of different climatic conditions to be happening very frequently. And that is very unique. And that also influences the type of food habits that we have, the type of clothing habits that we have, and also the occupation overall. For India, monsoons are not only a provider of rain, they are a provider of life. That is why when the years come, when the monsoons they fail in terms of the fact that they don't bring the adequate amount of rainfall that they should, that is the time when the entire agrarian economy collapses. Because in our country, the reality is that still more than 50% of the population is directly or indirectly involved in agriculture. If there is a lesser amount of rainfall, that has got its implications. Crops will fail. For example, even this year, despite the fact that July was extremely heavy amount of rainfall, August marked a significant scarcity of rainfall, where the amount of rainfall received was less than normal by almost 36%. Many areas in Karnataka, many districts in Karnataka, they were almost said to be drought hit, right? And same is the case with Bihar, same is the case with Madhya Pradesh, same is the case with Maharashtra. Agrarian crisis means the rural economy falters. And when the rural economy falters, the urban supply and demand parameter also goes out of sync. So that is when India suffers. So that is why you will still observe in many different regions of the country, you have special worship which is done before the monsoonal rainfalls in order to have, or they pray for adequate amount of rainfall, be it South India, North India, East, West, everywhere. You have groups and tribes and also the local communities. They basically carry out those special worships, veneration, anything that they possibly can in order to ensure that the monsoons and the monsoon gods, so to say, they are absolutely on the point. So that is why understanding monsoons is in fact one of the reasons why UPSC wants you to indulge in all this process of adiabatic heating, cooling, process of temperature, insulation, pressure, permanent wind system, etc. The purpose is obviously to help you understand the global climate, but all of that culminates in understanding India's monsoon. So that is how important it is. Now, for us Indians, the phenomena of monsoon was known to us for a very long period of time. We did not put an exact reasoning for it that why do we receive so much amount of rainfall only in these particular months, but the phenomena was known to us. Now, what is the meaning, exact meaning of monsoon? So, monsoon is derived from the term mausim, which refers to seasons. Okay, so that is what the term is derived from. So, you had Arab travelers. Arab travelers basically and the Arab merchants, they dominated the trade routes around almost 1,000 years back to 1300, 1400 years back. They dominated the trade routes. So the Arab travelers basically discovered that in the months of May, June, July, it is favorable condition to move to India because the winds in general, they are in the region of Arabian Sea, they are directed towards Indian coastline. And remember, in those times, the ships would be carried over by the wind and the wind movement itself. So they were aware of that, that you have a wind pattern, a wind movement, which basically will help you, will take you towards India. And they were also very certain that in the month of November, December, January, you have a wind movement which is exactly the reverse of it, which would help you move out from India after trading the goods, after carrying the mercantile. You can move out from that. So, based upon that, the term Mosim was coined, and that basically stood for seasons. And that is the genesis of the term monsoon. So, monsoon refers to, in its truest sense, monsoon basically means seasonal reversal of winds, where the wind direction completely ends up changing in between the different seasons. That is what the meaning of monsoon turns out to be. And as I told you, in many of the portions of the world, you have that the wind directions they change between the different seasons. But you have very few places where the wind pattern absolutely reverses itself. So that is why India is also referred to as the land of the true monsoon. And the climatic conditions are so varied that for a long period of time, it was understood, and the geographers on the across the world, they basically had a saying: if you want to study and understand the world, understand India. India is a mere reflection of what the world has. So, even in terms of the climatic parameters, very few countries you will find, other than, for example, such as maybe United States, in certain parts, Australia, China, only these larger countries, which experience a variety of climatic conditions, from hot deserts to very cold conditions. So, first of all, let us focus our attention into what are the factors which will influence the climate. Then we will move over to monsoon. And again, let me tell you, here, we will be following a different approach for covering of monsoons as compared to what is given in the book. In the book, generally, the entire mechanism is dealt with straightforward, that this is what happens. But there also, many of the portions are skipped out. Here, what we will do, first of all, we will discuss each of the factors. That, okay, these are the 7, 8 factors which influence the Indian monsoon. What are these factors? So that is something that we will discuss. First of all, we will understand each one of them, and then we will try to weave a story around them to understand the exact mechanism for the occurrence and the formation of monsoon. Okay. Now, first of all, the factors which influence the climate of the country. So, latitudinal extent of the country. And when we say latitudinal extent, India lies entirely in the northern hemisphere, lies entirely in northern hemisphere. So that means equatorial climate is not so much experienced or so much observed. Then basically Tropic of Cancer passes almost through the center of the country. Shiva, remind me about your doubt at a later point of time. I will definitely, and with the help of the image, I will let you know. Okay. Almost through the center of the country. Now, the Tropic of Cancer passes through the center. What is the meaning of that? And what is the implication of that? So that means the portion of the country that is the peninsular region to the south of it, that experiences a tropical kind of a climate, a moderate climatic condition. Whereas the regions to the north of it, to the north of Tropic of Cancer, they will experience subtropical and sometimes even temperate climatic condition will be experienced by them. So that is a common factor, that is a feature of this, which influences the climate as you end up moving from south to north or north to south. Now, had India, let's suppose, been lying on the equator, so almost the entirety of the country would have experienced the same climate. Had India lied between the region of Tropic of Cancer and equator, The entire country would have experienced a similar climate. But the region to the north experiences subtropical climate because of the fact that Tropic of Cancer passes through the center, and the sun's position at max is going to shine vertically on the Tropic of Cancer. Okay? Now, Himalayan mountains. Well, an essay can be written about the importance of Himalayas for India. And questions have been asked in UPSC multiple times about how Himalayas play a role. The Himalayan mountains to the north, they form the true natural frontiers for India. They form the true boundaries of India. Historically, the Himalayas have protected us, not only in terms of the vagaries of the climate, but Himalayas have also stood as a shield against the enemies who have tried to invade India from the northern portion or the western portion in certain cases. While the Mongols, the Huns, everyone, they could not come through the Himalayas. That is where it is a natural frontier. But then, its role in terms of shaping our climatic conditions is almost unparalleled. How? Because when we talk about the presence of the Himalayan region, understand that during the summer season, when you have warm winds coming from the region of these oceans, warm and moist winds, had the Himalayas not been present, they would have simply managed to cross over. But because of the presence of Himalayas, these winds, they basically are restricted and they cause what kind of rainfall? Orographic rainfall. Isn't it? Imagine if there would not have been the Himalayas. Northern part of the country would have been significantly drier, right? Because if you take a look at the latitudes, in the same latitude where India is, if you take a look at the other countries to the west, almost all of them are deserts. If you take a look at the similar latitude, even in other continents, almost all of them are deserts. India is not. That is because of the presence of the Himalayas. So that is where the role of the Himalayas are quite significant. Okay, not only that, the Himalayas also end up protecting us from the very cold winds which come from the northern portion, right? From the Siberian region. Many of the times you have very cold winds, especially during the winter, which comes over. The Himalayas forms a climatic divide. So basically, they protect the subcontinent from the cold northern winds. Along with that, when we talk about the role, stop the moisture carrying winds. From the nearby seas. And causes orographic rainfall. Okay, so that is the influence that the Himalayas play. Then comes the relief features. Relief means the topographical features that you have. Across the country, you have a wide variety of relief features. Now, these relief features, they influence the amount of rainfall that different parts of the country end up receiving. So basically, the physiography or relief also affects the temperature, air pressure, direction, and the speed of wind, and the amount and distribution of rainfall. So they offer obstruction to the winds and cause orographic rains. Okay, they provide obstruction to the winds and they end up causing orographic rainfall in the process. And also that means the leeward side of these relief features, they are going to be drier and significantly much more drier as compared to the windward side. So here, windward side of Western Ghats and Assam and Meghalaya receive very high amount of rainfall, whereas the southern plateau remains dry because they are present on the leeward side of the Western Ghats. So that is how they impact us. Overall, if you think about it, if you try to understand it, so here also you have the Himalayan mountain ranges, isn't it? Here you have the Garo Khasi, Jayantia. Now, when the moist winds from the nearby oceans they come over, so think about it. First things first, they will encounter the Western Ghats. So the western side of the Western Ghats, they start receiving very heavy dosage of rainfall. Now, after that, when we talk about these winds, these get directed from here on. So the Vindhyas and Satpuras, in between them, you have the Narmada Rift Valley system. They end up channelizing the winds here, and the central portion of the country also ends up receiving rains. Then, when we talk about the region of the Northeast, so here, when the moist winds come over here, after hitting the Himalayas, one portion goes here, other portion reaches here. Now, observe what happens to the portion which goes into the Northeast. It gets stuck in between these mountains, right? Almost a funnel like effect is created. Where there is an entry, there is not much of an exit out of it. So that is why the northeastern regions, they receive very, very heavy rainfall. Okay. And then when the moist winds, they come over furthermore. Now they encounter the some portion of southern part of Aravali. So here some amount of rain will be observed. But the rest of the Aravalis, they are parallel to the direction of the monsoon winds. And had the Aravalis had a different alignment, a different kind of a directionality, they would have impacted the rainfall. But here, they are parallel. So that means all these monsoon winds, they move straight ahead, they move straight forward, right? And that is the reason why Rajasthan continues to remain a desert, right? Rajasthan continues to remain a desertified area because of this factor. Okay, so that is basically what you observe as the influence of the relief features over the climatic conditions of India. Now, this is also the reason why, as you move from west to, or as you move from east to west, south to north, the amount of rains in the country keeps on decreasing. Okay, now the distribution of land and water. Now, India is also referred to as the peninsular region. Why? Because for a significant portion, the land is surrounded by water from three sides. That is what a peninsula is. Now, because there is a distribution of water in such a way, there are two impacts of it. First of all, for a large portion of the peninsula, the climatic conditions, the temperature conditions, the weather pattern, that is almost moderately consistent throughout the year. Okay, so the impact of it, when we talk about the impact, so large areas along the coastline experience consistent moderate temperature. And also, to add on to the fact that during the summers, when the land will get heated up at a much faster rate as compared to the water body, that is something that we have seen, that whenever there is heating, the land will get heated up at a much accelerated pace. So as the land gets heated up at an accelerated pace, you have development of low pressure over the land. Water continues to remain comparatively cooler. So that means here you have a comparative high pressure. A comparative high pressure. So that basically means that from high pressure to low pressure, you have winds which can come over. And because these winds are coming over from the water bodies, they will be rich in moisture and they will bring substantial amount of rains. So here, during the summer heating of land creates low pressure, right? And then water nearby is high pressure, which basically means what? Winds move onshore and bring heavy rains. Okay, Gaurav, this year northern states faced huge rainfall because the western and the eastern winds both reached the state. No, that happens every year. This year, the northern portion received rainfall because the monsoon phenomena did combine itself with the western disturbances. Okay, so that is a very rare occurrence, and that is something which is an indicator of how fast the climate is changing around us. And if western disturbances can combine, if they will combine with the monsoon, they can wreak havoc. And year after year, if this process continues, we can basically be a witness to very frequent natural disasters, which will basically be commonality in the northern states. So we will come to what is that western disturbance and what is that monsoon phenomena. You will be better aware of that. Now, then the factor of altitude also comes into play. When we talk about altitude, so height of different regions is different. It is not consistent over every areas. Now we do know that temperature reduces with height as a factor of the normal lapse rate. With increase in height, the temperature always reduces. So that also means that the temperature variation across different parts is different. For example, Agra and Darjeeling, they are located at the same latitude. Elevation of Darjeeling is basically 2000 meters, right? But Agra is around 171 meters from the sea level. So that is why temperature in Agra is around 16 degrees Celsius, whereas the temperature in Darjeeling, what you will experience, is close to around 4 degrees Celsius. So that is where you will observe, for example, even if you take the case of, let's suppose, Chennai or Uti, both of them are very similarly placed in terms of the latitudinal extent. But then the temperature in Uti is very different from the temperature that you observe in Chennai. Right. So altitude also ends up influencing the climatic conditions. So these are the various factors which influence the climate of the country. Okay. Now we come to the factors influencing the Indian monsoon. We will basically be taking a look at each of these factors, what they are. We will be familiarizing ourselves with what each of them are. And then we'll try to understand how do they influence the monsoon. So first of all, Indian monsoon is impacted by a host of factors, beginning from the differential heating of land and water, creating that pressure difference, the shift of the ITCZ, which happens between the seasons, the shift of the position of the ITCZ, that is significantly responsible for the various different wind patterns which are generated. Subtropical westerly jet stream, remember the subtropical jet stream? That also has got a significant role to play in influencing the onset of monsoon. Heating received by the Tibetan plateau and the tropical easterly jet stream, which is generated from there, that also strengthens the monsoon, or basically, if it is absent, the monsoon goes normal. Then the Mascarene High. It is basically a high pressure around the Mascarene Islands that you will find in the southern Indian Ocean. It is that high pressure which becomes a supplier of wind system towards India, which reaches India and causes the monsoonal rains. So this is high pressure around Mascarene Islands. Okay, supplier of winds coming to India. Then you have the factor of El Nino Southern Oscillation. We have seen that Enzo cycles, they influence the Indian monsoon. El Nino conditions reduce the amount of rain. La Nina conditions increase the amount of rain. But why? We will take a look at it. And then you have the impact of Indian Ocean dipole as well. So let us start taking a look at each one of these factors one by one. We will start by, first of all, the heating of the land. Okay. Now, when we talk about the heating or cooling of land here, during the summer season, in fact, this was one of the first explanations provided for monsoon. One of the very initial uh, explanation for the mechanism of monsoon, which was provided almost centuries back, a couple of centuries back, was simple. That look, the land gets heated up, and when the land gets heated up, it will develop low pressure. Nearby water bodies are comparatively cooler, so there will be a comparative pressure difference. That means the winds will be in motion from that water body to the land areas, and these winds will bring the moisture along with them, and that will cause sufficient amount of rainfall. It is these winds which will carry the moisture and they cause rainfall. So this is one of the major factors why the monsoon phenomena happens or occurs. But this is not the only factor involved. There are a lot of other factors at play as well. But that existence of low pressure due to the heating, that is significantly responsible for generating the low pressure which attracts the wind. So during the summer season, the land becomes extraordinarily hot. The nearby water bodies are cooler in comparison. As a consequence, cooler moisture-laden winds from these water bodies hit the landmass, causing rains. Now, then you have the other important factor, that is the shift of the ITCZ. ITCZ, remember, ITCZ is at the center or of the two Hadley cells which are created. So ITCZ is a zone of absolute thermal low pressure, isn't it? So this is a zone of thermal low pressure. Okay. Now, this changes or this ITCZ shifts in between the different months depending upon which area is receiving what amount of heat. For example, from the time of April, May onwards, you start experiencing very high temperatures, especially in the northern part of the country. In many parts of North India, the temperature frequently touches, and not only touches, but crosses 40 degrees Celsius easily. Thar Desert gets very much heated. The northern plains experience very high heat. So that is what creates that thermal low pressure. And the ITCZ slowly and steadily, it gradually moves and covers the entirety of the subcontinent, and it reaches its position in the northern part by the month of July. Again, in the month of January, observe, it will come here. But in the month of June, July, May, June, July, that is when the ITCZ comes over the northern part of the country. And it passes through very hot areas, the Sahara, the Arabian, the Rub al Khali, the Daste Lut, the Daste Kavir, all these deserts, the Balochistan region, the Thar desert area. So these are the absolute thermal low pressure regions which get created. Now, here, let me first of all clarify one thing, that this transition or this movement, it is not a one-time movement that immediately the ITCZ will suddenly reach the northern part. No, it is a slow movement. So that means in the month of April and May, that is when the movement is initiated. In the month of April, you will observe the ITCZ to be here. Progresses slowly. By the month of May, the ITCZ reaches here. Right? By the month of June, the ITCZ reaches here. And furthermore, right? Now, how is it that we can interrelate it, particularly to the cyclones? Remember, I had told you that in India, cyclonic season extends in the month of April, May, June, and then eventually in the month of November and December. So this has got to do with the ITCZ. Because in the month of April, May, and June, when the ITCZ is over these areas, that means what? In the water bodies, you have a pre-existing low pressure, because ITCZ is a region of low pressure. So in these areas, the ITCZ basically is a region of low pressure. That is the reason why in the month of May, April, May, and early part of June, you will experience this particular cyclonic events to happen in India. And then in the month of July, later June and July, when ITCZ lies completely over the territorial part, over the land areas, then you won't experience any of these parameters working anymore. Then you won't experience the occurrence of cyclones anymore, because then you don't have a pre-existing low pressure over the water body, do you? So that is how this movement of ITCZ is also responsible for the occurrence of cyclonic disturbance. Having said that, when we talk about this ITCZ, let's suppose in the month of June, the ITCZ has established itself here. Okay, let's suppose this is your ITCZ. It establishes itself here. Now, ITCZ is a region where you will observe the convergence of the tropical winds, both from the northern hemisphere as well as southern hemisphere, isn't it? You will observe the convergence of the wind systems here. This is what is the Hadley cell. Now, if the ITCZ is here, the northern component of the Hadley cell, that will be obstructed by the Himalayas. But what about the southern component? The southern component would be very much active. So that is where you'll find the trade winds in the southern hemisphere originating from the region of the mascarene high pressure mostly. The trade winds, they basically, they come like this. Then they will cross the equator. And then they will have a bend like this. Their ultimate aim is to reach the ITCZ. Okay. In that process, they hit the. But if I ask you, what is the direction from which they are coming to the Indian coastline? The answer is very simple and straightforward. The direction is southwest to northeast, isn't it? So the wind pattern is southwest to northeast in the month of June, July, and August. Wind pattern is southwest to northeast. Now, because the wind pattern is from southwest to northeast, that is the reason why this particular monsoon is also what is referred to southwest monsoon or advancing monsoon, because they overall cover the country from south to north with the movement of the ITCZ. And remember, the winds are named after the direction that they originate. Hence, these are what are referred to as southwest monsoon. Southwest monsoon. Okay. Now, just to show you how the winds behave, this is the satellite image of the winds. Observe the movement of the winds. Observe how these winds, they cross the equator. At equator, zero Coriolis force. So again, they start bending, and observe how they hit the land. Right? So this is the direction of the winds that you experience. So the ITCZ is the zone indicating lowest pressure in the tropics. It is in that zone that winds from both the tropics, they end up converging. The ITCZ moves to the north and south with the apparent movement of the sun. As the sun moves, so does the ITCZ. During the monsoon months, the ITCZ passes through the northern part of India, And this attracts winds all the way from the southern subtropical high pressure bed. Now, this wind covers a large oceanic area before hitting the land, right? So that means they are rich in moisture, right? Hence bring rains. Okay, so that is the feature that you observe. Why monsoon winds does not move towards Arabian region, Afghanistan? Because obviously, see, the monsoon winds here, they will be deviated, or Gaurav, they will be diverted to the right. Because of Coriolis force, they will bend to the right. So how will they reach there? Here the wind systems will be there, but those winds will be dry, right? So that is why these regions continue to remain a desert. uh, Satish, then the cyclonic rainfall will also be the occurrence. Yes. Priya, isn't trade wind from northern hemisphere going to affect the winds coming from southern? No. Why will they affect? The trade winds from the northern hemisphere. See, the northern component of the Hadley cell will have the trade winds coming in this area, but they will never be able to cross the Himalayas, the mighty Himalayas that you have. The winds will never be able to cross a mountain system which is having peaks to the height of 8 kilometers, 7 kilometers on a frequency, and that to spread over a large area. That is something which is not possible. Okay. Now, then, till now, is it understood? Are the factors clear up till now? Good. Now we come to the role played by the subtropical westerly jet stream. The subtropical westerly jet stream, that is a permanent jet stream that is in existence in the northern part of the country. And this subtropical westerly jet stream obviously will have during a kind of a shift between the seasons. Okay, we have seen that the jet streams can move north and south. So the jet streams will also be moving with the shift of the ITCZ. I hope we are aware of that. Now, what happens during the winters? During the winters, the ITCZ shifts south, isn't it? When we have the winter season. So during the winters, as the ITCZ shifts south, so does the subtropical westerly jet stream along with that. Is Red Sea unable to provide moisture to the winds from Africa? Absolutely. Red Sea is very, very narrow. Red Sea is very small. So that is why it is basically almost negligible in terms of the moisture content that it can provide. And at max, Red Sea can provide small land breeze and sea breeze in the nearby region and provide a moderating influence on climate. But that's it. Gaurav, what is the cause of non-monsoonal rainfall that north gets in late December and February? It is the western disturbances, my dear friend. Western disturbances create that rainfall. Okay. Until again, as is the case with your previous question, we have not come to western disturbances, so I won't be able to elaborate any further than that. Now here, these jet streams during the winter season, they will shift south along with the ITCZ. So during the winter season, if you were to think about the existence of these jet streams, they would be somewhere in this area. But then, due to the obstruction posed by the Himalayas, they basically divert. You have a distinct northern branch and a distinct southern branch. Okay, that is something which is existing during the winter. Now, during the summer, the ITCZ shifts north. So the Hadley cell shifts north. And the subtropical jet stream is between the Hadley cell and the Ferrel cell, right? In the upper atmosphere, the subtropical westerly jet stream is generated where? Between the Hadley and the Ferrel cell. So as they shift to the north, this jet stream will also start shifting to the north, isn't it? So as the summer season comes, the jet stream starts shifting to the north. So this starts shifting to the north. So as this entire jet stream over thousands of kilometers they shift to the north, means what? It means the northern branch continues to get stronger. Much more air is supplied from this area itself. And the southern branch continues to get weaker and weaker by the day. Southern branch continues to get weaker and much more weaker by the day. Eventually, a situation comes when the southern branch disappears, right? Because the southern branch simply cannot cross over the Himalayan region. That is simply not possible. So a situation comes when the southern branch eventually disappears. And when the southern branch disappears, that is what leads to the onset of monsoon. So think about it, every year, monsoon occurs because of the same phenomena of heating and cooling. But every year, it is not the case that the monsoons will happen at the same time. When it comes to the prediction of onset of monsoon, in few years or in certain years, you observe that the time is or the date is basically last of May or the first week of June and so on, right? So there is a variation in that. So why is that the case? Because of unpredictability of the southern branch of this jet stream. So by the time of the May and June, ITCZ has also come over to the northern part of India. But still you have the southern branch of the jet stream still being persistent. Weaker, much weaker, but still persistent. And remember, as long as the jet streams are there, they won't allow the mixing of air in between the different regions. That is when the northern part of India continues to warm up, continues to get heated up quite significantly, much more as well. And eventually, what happens? Eventually, the moment this southern branch of the jet stream disappears, immediately all the winds they get activated. Suddenly they will start hitting all the wind systems. They start hitting, and that is when it hits the Kerala coastline. It causes rains in the region of Kerala. Okay, and we say that it has been the onset of monsoon. Okay, so the onset of monsoon is very much dependent on the southern branch of the jet stream and its disappearance. So when we talk about, so the subtropical westerly jet streams are the jet streams which tend to develop over the region of the subtropical high pressure belt. Now, during the winter months, these jets, they lie over the northern part of the Indian subcontinent, having a distinct northern and the southern branch. With the onset of the summer season, as the ITCZ shifts north, the southern branch of the jet stream starts to weaken. Eventually, when they disappear, eventually, when the southern branch suddenly disappears, the winds rush in to the areas causing high amount of convection in the heated regions and cause very heavy rains. Onset of monsoon. Okay, that is how we experience the onset of monsoon. How southern part of the jet stream disappeared? Because see, during the summer season, you have the entirety of, if I have to present the cross sectional view of it, let's suppose if if we consider this as the ITCZ, now you have the presence of a circulation system here. Okay, here is where you have this jet stream. So as this ITCZ will move to the south, this jet stream will also tend to move to the south. But during the summer season, the ITCZ shifts north. So this jet stream will also shift north. So this jet stream entirely over the region of Mediterranean and so on start shifting to the north. And that means strengthening of the northern branch and weakening of the southern branch. The southern branch will continue to weaken, and further weaken. Eventually, a situation will come when the southern branch gets so weak that it disappears. It is not going to be the case that if you have, let's suppose, the Himalayas here, the southern branch is going to come from here, will rise up and then shift north. If that would have been the case, the jet streams would have been in existence over the region of the Himalayas as well. Okay, so that is how it is the shift of the entire monsoon, or the shift of the entire jet stream northwards, that is leading to the weakening of the southern branch and eventual disappearance of the southern branch. Is that understood, Ganesh? Okay. Now, we move ahead with another factor, and that is the heating of the Tibetan highland, the heating of the Tibetan plateau. Now, Tibetan plateau is present at an elevation of around 5 kilometers, right? 5 kilometers from the surface. Now, what that means is basically at that elevation, you have hard rocks of the plateau, very, very hard rocks of the plateau present at very high elevation. Right. So even if the Tibetan highlands, they gain a temperature of around 10 degrees Celsius, 15 degrees Celsius, 20 degrees Celsius, that also is sufficient to create a very strong low pressure system. And these are basaltic rocks. Basaltic rocks, when they get heated up, they basically generate a lot of convection current. Right. They get heated up because of the factor of albedo. They gain very high temperature. So these Tibetan highlands, they get heated up, and they are the highest plateau of the world and comprise of rocky structure. As a result of this, heat is gained and lost very quickly by these rocks that you have. So what happens actually? When we talk about the region of the Tibetan highlands, let's consider a cross section here. Let's consider this as the Himalayan mountains and the Tibetan highlands thereafter. This is at an elevation of 5 kilometers. Now, during the summertime, the temperature is around 15 degrees Celsius, let's suppose. Right? Let's suppose during the summer season, the temperature is 15 degrees Celsius. Now, you might think that 15 degrees Celsius, is that enough to generate that low pressure? It is more than sufficient. Why? Because if you compare it with any other region to the south of Himalayas, let's suppose the northern plains, etc. Now, there the temperature at the ground surface is how much? 40-45 degrees Celsius during the summers, isn't it? So let's assume the temperature here is 40 degrees or 45 degrees. Now, here, if you move higher up, in temperature in this area. We are talking about the summer season. Summer season means generally dry conditions. So you will have a dry lapse rate, isn't it? A kind of a dry lapse rate. So dry lapse rate roughly around, think about it, 10 degrees Celsius per kilometer. So what will be the temperature at a height of 5 kilometer above this area? Think about it. If the dry lapse rate is around 10 degrees Celsius per kilometer, what will be the height at the what will be the temperature at the height of 5 kilometers in this area? What do you think? Good. 75, 95. I hope you guys understand that you will have to clear the CSAT examination before having any shot at the mains examination. 35 minus 20. If the temperature is decreasing at the rate of 10 degrees Celsius per kilometer, temperature at a height of 5 kilometers from a base of 45 degrees Celsius, how does it turn out to be 95 degrees Celsius? Okay, stop. Stop putting up the answers. I will tell you the answer. The temperature at the height of 5 kilometers will be roughly around minus 5 degrees Celsius. Okay, so that is the temperature that you generally experience at this height. But here in Tibetan highlands, the temperature is 15 degrees Celsius in comparison, which is huge, which is very high. So here you will have an intense low pressure creation over the region of the Tibetan highlands. And because you have the intense low pressure creation or existence, what does that mean? Air will rise up very quickly. Air will rise up very quickly. And the air is already rising from the base height of 5 kilometers above sea level. So very quickly, it will be hitting the region of tropopause. So it hits the region of tropopause very quickly. And as soon as it hits the tropopause, it will diverge. In all the different directions, it will diverge. Okay. Now this air or this wind moving in the upper region of troposphere, it further moves ahead. And it takes a direction. Basically, if you have to imagine it, think about it, that the air is rising from this area. The vertical rise is happening. After that, it will diverge in all different directions impacted by the Coriolis force. One of the directions in the upper air that they will take is the Kolkata-Hyderabad axis, as it is known as. They will cross the equator. They will be crossing the equator, bending to the left, and eventually they will be sinking in the region of the subtropical high pressure belt. So they will cross the equator. They will hit the ground somewhere where you have sinking air at the region of the subtropical high pressure belt. So subtropical high pressure zone. Okay. And when they will increase, basically if the wind is falling in the region of subtropical high pressure zone, they will increase and intensify the intensity of the high pressure. High pressure gets stronger, right? So the high pressure gets stronger. And we do know that in India during the monsoon months, winds are coming from the region of subtropical high pressure in the southern hemisphere. So that means more winds will be driven towards India. Okay. More winds are driven towards India. And all these winds will be crossing large areas across oceans. So they will be very, very rich in moisture, and they will be able to cause substantial amount of rainfall in the process. So this means more winds towards India. So overall, this heating of Tibetan highland plays an important role in influencing the monsoon climate and the amount of rainfall received in the monsoonal months. Here, because of the heating, you have the occurrence of that high altitude wind in the region of the top of troposphere. And that wind moves at a speed of 80 to 90 kilometer per hour. 90 kilometer per hour. It is moving in the region of the tropics. It is moving in a direction of east to west, and hence this wind is also what is known as the tropical easterly jet. This is a temporary jet stream which comes into existence, and that temporary jet stream brings about the strengthening of the Indian monsoon. So, if let's suppose in certain years during the month of December, Tibet has received a lot of snowfall, lot of ice cover is there. And by the time of May and June and July, all that ice has not been able to melt. Then what happens? In that situation, the heating of Tibetan highland is not complete and completely successful. So in that situation, you won't have this tropical easterly jet which will get created. So the monsoon will go according to the normal phenomena. But if let's suppose the snowfall received in the winter months is less and Tibet becomes ice free by the time of April and May, maybe by June, so then the heating of the Tibetan highland, which will be observed, will lead to substantial low pressure getting created, generation of a very strong tropical easterly jet, and strengthening of Indian monsoon. So this is a very important factor when it comes to the influence of Indian monsoon. So this is the upper air movement of the tropical easterly jet. Easterly jet. And here, this high pressure, when it gets strengthened, this will drive the surface winds. More surface winds will be coming over to India. These are your surface winds. Okay. So that is what brings about the strengthening of the Indian monsoon. So step-by-step process is that during the summer months, these rocks in the Tibetan highlands, they become very, very hot. So what that means is they form an intense low pressure region over the area of Tibet. Resultantly, the air rises up and then diverges from a particular height. The divergent air goes all the way to the southern hemisphere and sinks over the mascarene high, right? That is the high pressure, the subtropical or the subtropical high pressure in the southern hemisphere. This represents subtropical high pressure in southern hemisphere, right? This upper air movement is sometimes referred to as a tropical easterly jet. And this forms an important cycle to strengthen the monsoon. So, stronger the tropical easterly jet or greater the heating of the Tibetan highlands, more stronger is the monsoon phenomena created as a consequence of it. Then, the role played by mascarene high. That is the high pressure in the southern hemisphere, and that is the subtropical high pressure that we have. So, in the southern hemisphere, around the region of the Mascarene Islands, that is where you have the presence of the subtropical high pressure belt. This is where you will have the presence of subtropical high pressure zone. This high pressure zone becomes the supplier of the monsoon winds coming over to India. Okay, they become a supplier of the monsoon winds. So basically, stronger the high pressure, stronger the mascarene high pressure, more will be the winds coming over to India. Weaker the high pressure, less will be the amount of winds coming to India. More winds mean more rainfall, less winds mean less rainfall. Okay, so strength of the mascarene high pressure is directly proportional to the strength of the Indian monsoon. So overall, a zone of high pressure which exists around the Mascarene Islands in the southern hemisphere, and hence the region is referred to as Mascarene High. Now, during the monsoon months, when it is winter in the southern hemisphere, this region of high pressure is a source of the wind which reaches all the way to the ITCZ, which lies over India. Now, stronger the high pressure, more is the rainfall received during the monsoon season. Okay, if by some factor or the other, let's suppose the high pressure is weakened, the amount of rainfall received is also lesser. Now, then comes the impact of El Nino and the La Nina conditions. How do they influence the monsoon? So we do know the basic factor that is required for your examination. El Nino reduces the amount of rain. La Nina will increase the amount of rainfall created, right? That increase the amount of rainfall observed. But when we talk about this, how does that play out? So, first of all, heating of oceanic waters in Pacific, which ends up creating the Enso conditions, they have an influence on the monsoon. Conditions of El Nino decreases the overall rains received by India during the monsoon months, and the conditions of La Nina leads to a surplus amount of rainfall during the monsoons for India. But how does that happen? First of all, starting with La Nina conditions. Now we have seen the circulation created due to La Nina. Now here, rather than the Pacific, we'll focus our attention to the region of Indian Ocean. Now in the region of Indian Ocean, here is where you have the mascarene high pressure. Now what do you think will be the influence of this La Nina circulation? Will it increase the high pressure at mascarene high, or will it weaken the high pressure at mascarene high? What do you think? Here, if you notice carefully, you have a sinking air column, right? You have a kind of a sinking air column which is present. So that sinking air column means what? It means the high pressure will be strengthened, isn't it? So when that high pressure will be strengthened means what? It means better monsoons. So that means higher rainfall. That is why during La Nina, we experience higher amount of rainfall. Okay, so basically due to the conditions of La Nina, basically in Western Pacific there is a creation of low pressure over the region. The air rises up, forms clouds in the Western Pacific. After that, diverges from the top of the troposphere in the eastern and the western directions. The part which moves to the west towards the Indian Ocean eventually subsides in the region of the mascarene high, thereby strengthening the mascarene high pressure. This strengthens the intensity of the monsoon winds, causing more rains. During El Nino, something different happens. Again, during El Nino, if you observe that this is the circulation created in the Pacific due to El Nino, observe what happens in the region around Mascarene High. Here you have a rising air column in the close vicinity created due to the impact of El Nino. Now, when you have a rising air column, what will be the impact on Mascarene High? The high pressure will reduce, the high pressure will weaken. And when the mascarene high pressure gets weakened, lesser winds come over to India. That means lesser amount of rainfall in India. Okay, so that is how El Nino basically leads to lesser or reduced amount of rains. So basically here, the in general, it weakens the high pressure system in the existence of the in existence in the region of mascarene high. And when the in high pressure at mascarene islands they are weakened, the intensity of the monsoon winds also will weaken in the process. So that is how El Nino and La Nina ends up weakening the monsoon system or strengthening the monsoon system. Then comes the role and the influence of the IOD. IOD also influences and impacts the amount of rains received in India. And here we have seen earlier that whenever you have negative IOD or neutral IOD, that means lesser rainfall. Negative or neutral, less rains in India. And when you have positive, high amount of rains, in India. Okay, so let us understand how. So basically, during negative and neutral conditions of IOD, which part of Indian Ocean has got the low pressure? Eastern or western? What do you think? During negative and neutral? Correct, Ganesh. Correct. Absolutely incorrect. Atish. Justin, correct. Suresh, correct. So basically, during the negative or the neutral phase of IOD, you have a low pressure system which gets created in the eastern part of Indian Ocean. We have just covered it, guys. You cannot afford to forget it so soon, unless and until it is all turning out to be a hodgepodge. In that case, please let me know. So here you have a low pressure which develops. Now this is the region of a mascarene high pressure. This is your area of the ITCZ. ITCZ. Ideally, the winds from here, they get directed and they reach here. Okay. But now, because you have a competing low pressure in this area, means what? This low pressure means that the winds will no longer be reaching that Indian coastline, right? You won't have the winds reaching the Indian coastline, but rather you will observe the winds getting diverted towards here. So that means what? During negative or neutral phase, you have lesser amount of winds which reach the Indian subcontinent. And that means lesser rains in India. Okay. On the other hand, if you have a positive IOD creates a lower pressure in this entirety of the region. So that means all the winds, rather than coming anywhere else, all the winds will be directed towards the region of that low pressure. It will act as a channel, as a conduit, supporting and directing winds towards the ITC set. So that is why during the positive IOD, because you have low pressure conditions in the region of the Arabian Sea, in the region of the Western Indian Ocean, it will act as a supportive low pressure, which will channelize the winds towards the ITC set. Whereas in the case of negative or neutral condition, it will divert it away from the Indian coastline. Okay. So these are the various factors. Now we take a look at the mechanism. Before that, I think we need a break. Let's take a break for 10 minutes. Refresh yourself. Try to get back and try to have that concentration. Whatever you need to do, try to think about it. And then we come back after the break and we cover the mechanism. So take a break for 10 minutes and we'll be back. A confirmation about the audio, please. If the audio is clear and available. Thank you. Ganesh, you had a question that how the tropical jet easterlies turn back to India in return path. Why doesn't happen obstruction? Where did you gather that it basically, why will it have a return path? Tropical jet easterlies. First of all, understand, Ganesh, listen to this carefully and understand. Tropical easterly jet is moving at a higher altitude, and you have the surface winds which bring rainfall. These winds, they don't bring rainfall. It is these winds which will hit the coastline, which will basically hit the land, and that will bring rainfall. Okay, so when we talk about the tropical easterly jet, this rises up. This is the upper air movement. This is your upper air movement. Air movement. This is your portion of surface wind movement that you experience. So from the upper air, the wind basically comes in, the air comes in, and it sinks in the region of the high pressure. In the region of the high pressure. From here, you have the surface winds which get generated. These blue lines that you see, these are moving at a surface. So one of them is moving at a height, another one of them is moving at the surface. So how do you think they will have an obstruction against each other? Okay, I hope that is clear. Now, then we come to the mechanism of Indian monsoon, or the mechanism of the southwest monsoon. So southwest monsoon, basically the name is denoted why? Because the wind speed in general is from southwest to northeast. That is the direction of the wind motion. Now here, how is it that the entire process unfolds? First of all, initially, during the months of March, April, from that point onwards, the heating is initiated. The land starts getting heated up, the temperature rises up in the range of somewhere around 40 degrees, 45 degrees. Thar desert in Rajasthan gets substantially heated up. So the entire portion substantially gets heated up. Now, what that means is that the low pressure will be created on the ground surface, but also the ITCZ, it starts moving northwards. Okay, the ITCZ starts to move northwards. And the ITCZ eventually reaches this position by the month of June, or by the month of late May, June, July. This is the position of the ITCZ. Now, what that means, from the region of high pressure in the southern hemisphere, that is the Mascarene High. Here, this is the subtropical high pressure. From here, winds on the surface, they are trying to reach the ITCZ. That is their destination. In the meanwhile, they cross the equator. That is where the direction changes. They cross the region of the equator, and they basically will hit the landmass. And they bring about substantial amount of rains over the Indian subcontinent. Now, here, till this point of time, as the air reaches the Indian coastline, they won't cause rainfall. They won't bring rainfall. Periodic rain here or there due to convection might happen, but they don't bring the onset of the monsoon. Because up till this point, that is in the month of late May, up till that point, you will always observe that the southern branch of subtropical westerly jet stream, that is still in existence. So as the rest of the jet stream, it starts shifting to the northern portion, and the northern branch becomes stronger and stronger. The southern branch of the jet stream gets weaker, and eventually it disappears. The moment the southern branch disappears, almost immediately, you will observe that the winds, they will hit the land. Okay, the moment the southern branch disappears, the winds will hit the land, and there will be convection which will happen both in the lower surface level as well as the mid level of the troposphere. So you will have very dense and very thick cumulonimbus cloud. And suddenly you will have excessive amount of rainfall received in many parts because of that clearance provided by the subtropical jet stream. And that is what we also sometimes refer to as the burst of monsoon, when you have that sudden convection happening both at the lower level as well as the upper level. You have high amount of and heavy amount of rainfall received. That is also the burst of monsoon. Now after that, in the month of June and July, in the meanwhile, you will observe that there is substantial heating of the Tibetan highland as well. Tibetan highland, and when it gets heated up, it generates a wind pattern in the upper atmosphere, that is the tropical easterly jet. The tropical easterly jet will be the movement of wind in the region in the upper troposphere, and that tropical easterly jet will strengthen the surface winds reaching the Indian subcontinent from the Mascarene High. So, in a way, it strengthens the Indian monsoon. Okay, so the Indian monsoon strengthens as a consequence of it because of this tropical easterly jet, and that is when you have the full-fledged occurrence of rainfall and full-fledged occurrence of monsoonal phenomena. Now then, the depending upon whether you have the condition of El Nino or La Nina, you will experience that the amount of rainfall is reduced or is increased. In case you have the conditions of La Nina, India will experience higher rainfall than average. In case you have the conditions of El Nino, India will receive less than normal rainfall. So that is something which you observe as a phenomena, as the mechanism of the entirety of Indian monsoon. And Indian Ocean dipole can counteract the influence of El Nino and La Nina, where when you have the positive Indian Ocean dipole, means more rainfall, negative and neutral Indian Ocean dipole means lesser rainfall. So it all starts with the shifting of the ITCZ, dragging the winds from the southern hemisphere, winds coming over from the region of the southwestern direction, hence the name southwestern monsoon. Now, they will bring sufficient amount of rainfall over the Indian subcontinent, and the onset will still not happen as long as you have the southern branch of the subtropical jet stream. The moment the southern branch of the subtropical jet stream disappears, that is when the winds will rush in all the moisture that they have carried. That will form clouds in the form due to the convectional process, and that will bring sufficient rains. Okay, so that is the entire mechanism of the southwest monsoon condition. Is that understood? Or do we have any doubts in the process? Understood? Okay. Now we talk about the retreat of the monsoon. Now, if you have followed the news headlines a couple of days back, the Indian Meteorological Department declared the complete of the retreat of the monsoon. Now, when the monsoon comes over, by the way, when the monsoon phenomena comes over, initially the rains will be received in some portion only in the southern part. That is, Kerala coastline receives rainfall first. Then, within a week or 10 days, you also have rains received up till the Maharashtra coastline. In the meanwhile, from the eastern part, the winds which are coming in, these winds, they will hit the Himalayas. One part will get trapped in the northeastern portion. The other portion here starts traveling to the west. In the meanwhile, between the Vindhyas and Satpura, you have another branch of the Arabian Sea monsoon, Arabian Sea branch of monsoon, basically, which reaches through the Narmada Rift Valley system. It reaches the area of central India, and it will cause rainfall in the portion of central India. Right? Now, these wind systems, they will end up covering the region, and because the Aravalis, they lie parallel to the monsoons or parallel to the monsoon winds, hence the western part of Rajasthan is completely dry as a consequence of it. And then this Arabian Sea branch of monsoon meets with the Bay of Bengal branch of monsoon in the region of the northern plains, further leading to rainfall in the area of Punjab, Haryana, Himachal. In those areas, you receive rainfall as a consequence. And in these areas, you have orographic rainfall, which is caused. So that is the distribution of rainfall. Now, during this season of, this is also the advancing monsoon as it advances and covers the entirety of the country. During the season of advancing monsoon, the Coromandel coastline, that is the Tamil Nadu coastline, ends up remaining very, very dry. This coastline remains dry. Okay, very dry for that process. And that means you don't have rainfall received in this area. But as you move from south to north and as you move from east to west, south to north and east to west, the amount of rains received keeps on reducing. Why? Because you are moving away from the source of moisture. Okay, so in a nutshell, when we have to talk about the distribution of the amount of rainfall, that distribution, first of all, in the region of the western coastline, you have the Arabian Sea branch of monsoon divided into three parts. One part straight away hammers into the western Ghats, causing copious amount of rainfall in the western part of western Ghats. One part goes through the region of the Narmada Rift Valley, causing rainfall in central India around Amarkantak plateaus and the hill region. Then the third part moves northwards through the region of the Thar Desert and into the area of northern India, where it combines with the Bay of Bengal branch of monsoon, bringing rainfall in that area also. So this is how the rainfall or the total amount of precipitation unfolds and occurs in the entirety of the country. Okay. Now, all these winds, they are getting attracted to India. Why? Is it because India is such a nice place, we are such a nice people? No. It is because in the ITCZ passes through India. ITCZ passes through northern portion of India. Now, which is the region where the monsoon will reach the last? It is the northwestern part of India. That is the region of Punjab, Haryana. There, it takes almost a month after the onset of monsoon for the rainfall to happen in the region of Punjab and Haryana. That is why Punjab, Haryana, they are generally dry even in the months of June. They start receiving rainfall in the months of July onwards. Right? Now, the ITCZ, as it has marched northwards, it will also continue its march southwards. Why? Because on 23rd of September, the sun is shining vertically over the region of equator. Because of the southward movement of the sun, in December, the solar position will be in above Tropic of Capricorn. So at 21st or 23rd of September, the solar position will be above the region of what? Above the region of equator, right? So as the position of the sun starts moving southwards, the ITCZ also starts retreating. The ITCZ initially starts retreating from the portion of northwestern India. So, northwestern India is the place where the monsoon reaches last and withdraws from earliest. It starts retreating from there earliest. Then the ITCZ follows the retreat. In the months of October, November, and December, the ITCZ generally lies over the region of India and some part in the associated Bay of Bengal and Arabian Sea. That is why, again, during the months of October, November, and December, you will observe cyclonic formations to develop in the region of Arabian Sea and Bay of Bengal. And why is that the case? That is because of the pre-existing low pressure which is created by these. And hence, they will start developing over these areas. They will start coming in existence over these particular regions. Okay? So, retreat of monsoon basically means what? Let's suppose the wind systems have, the ITCZ has reached here. Now, what will be the direction of the wind? Direction of the wind is generally northeast to southwest. Because now the northern trade winds system will also come into place, As the ITCZ is shifting south, the northern trade wind system will also come into place. So here, these northern trade winds, they basically try to reach the ITCZ. Now, while they are covering the land, they are mostly dry. So there they won't bring any rains. But some winds, as you can observe, they will cross the Bay of Bengal. And as these winds, they cross the Bay of Bengal, they will cause substantial amount of rainfall in the process. So that is why during the time of the retreat of the monsoon, wind direction is what? Northeast to southwest, right? Areas receiving rainfall. Tamil Nadu coastline or Coromandel coastline. The process of retreat is initiated somewhere in the time of 17th September, 15th September later, right? So it is initiated around 17th of September and it generally lasts for 1 or 2 months. The entire process of withdrawal of that ITCZ, that lasts for almost a couple of months, so to say, right? So that is substantial. So even if that rate of retreat is hastened, if it becomes faster, that means certain regions or the other will suddenly receive a lot of rainfall. Okay, so this process of retreat, or let me write it down in the next slide. So when we talk about the retreat, observe this retreat that is happening. Observe that 15th of September is when the ITCZ would be here, and slowly they retreat and withdraw themselves across the entirety of the subcontinent. The monsoonal cells, etc., they get withdrawn. So the process of retreat is generally initiated around 17th of September. Okay. Wind direction we have seen northeast to southwest. It takes close to 1 to 2 months for the entire system to withdraw from the subcontinent. Okay, it takes almost a couple of months, 1 month in general. This time it has taken 1 month for the entire process to withdraw from India. So that is the reason why in the month of October, so basically as this low pressure systems they start withdrawing from India, it is replaced by colder conditions. The regions they start becoming slightly colder, right? So that is where you have the establishment of high pressures. Now high pressures get established, get created. Obviously the subtropical highs, they get established back again. And that is why the winds, because they are coming over from the land areas themselves, they are completely devoid of moisture, right? The winds, so that is why they won't cause that much amount of rainfall. However, in certain parts of the country, after receiving prolonged rainfall through the months of July, August, September, by that point of time the amount of humidity in the air is very high. Okay, so when the amount of humidity in the air is very, very high, in that situation what happens? In that situation, heat is retained, but there is no rainfall because there is no low pressure. So that is when lack of rainfall, in certain cases high humidity means oppressive conditions, lack of no rainfall, again clear skies. So that means you have what is referred to as October heat. where in many parts of North India it becomes very oppressive, where neither there is rainfall, but there is heat retained because of the humidity which has been gained over these particular months, and that sustains itself, that persists itself. So that is the phenomena what you experience as October heat. Okay. Now, Suresh, why not rainfall on October month? Because the ITCZ is basically in the process of withdrawal. Right. And not only the ITCZ, the low pressure systems which have attracted the monsoons, they are in a process of withdrawal. So, where will the rains happen? The wind systems, the northern trade wind systems which will get established, these trade winds, observe here, they will be moving over from land area. So, do they get the moisture at all? No. So, that is why, because they are deprived of moisture, that is why they will not have any amount of rains. Okay. I hope that is understood, Suresh. Jaswant, will monsoon as a season will disappear due to climate change and will it be sporadic like in other countries? No. The system will not disappear completely, but yes, it will become very sporadic. It will have very distributed amount of, or very, in a way, disturbed amount of rainfall. That sometimes you will have very high amount of rain, then you have almost 10 days, 20 days of very dry conditions, then again very high amount of rain. So that is something that you will experience. Yes. Okay. Now, October heat. Okay. So during the month of October, you have to understand that before that, you have had 2 to 3 months of continuous rainfall in many areas. So the amount of humidity in the air is very high. And in the month of October, because the low pressure belt is shifting southwards, means there will be no rising air column, means you will have dry conditions, clear skies, right? So not dry conditions perfectly, but lack of rainfall, clear skies, no cloud formation. And October doesn't become very cold immediately. Later part of October, still some amount of cold conditions are in existence, but immediately it won't become very cold, isn't it? So in October, the heat experienced is further exaggerated by the humidity which is retained in the air in many parts of the country. And that is what is referred to as October heat. If there would have been a low pressure system, it would have caused rainfall along the way. But because there is no low pressure system, there is no rainfall, hence no relief. It is neither too cold to bring about some relief, nor is it so hot that it will create a low pressure. So you have a warmer condition where the temperatures or the conditions are much more oppressive because of the high humidity level, and that is October heat. Is that understood? I hope that is understood. Okay. Now, we come to another setting which happens basically in many of the books. You will find that northeast monsoon and the retreat of the monsoon, they are confused, they basically are mixed and matched as the one and the same thing, but they are actually very different. So when we talk about northeast monsoon, so this ends getting set up after the monsoon withdrawal is complete. Okay, after the retreat of the monsoon, this sets up after complete withdrawal of the monsoon. Okay, so when the monsoons completely they withdraw from that area, then what happens? You have this as the equator. The ITCZ would be setting up around somewhere around to the south of India. After the withdrawal of the monsoon has happened, the ITCZ would be setting up somewhere in the south. So let's suppose the ITCZ has been established somewhere here. Let's suppose. Let's suppose. This is where the ITCZ has set up. This is your ITCZ. Now, as this ITCZ has been established, now you will have the trade winds coming back into action. These trade winds, the northern trade winds, basically, they will have a movement like this, easterly to northeasterly, and they will be crossing the region of Bay of Bengal and hitting the Andhra and the Tamil Nadu coastline, that is the Coromandel coastline, will be substantially hit by them. So, what is the wind direction in this case? Wind direction is northeast to southwest. Regions receiving rainfall, again, Coromandel coastline. Receiving rainfall, Coromandel coastline. Okay. So that is where you will observe that again the eastern coast of India receives rainfall in these months. So this happens, for example, right now within a day or two, it is expected that the northeast monsoon is going to set up, right? Because the withdrawal of the monsoon has been completed from over the Indian subcontinent. So now within a couple of months, you will within a couple of days rather, you will observe that the northeast monsoon sets in. It brings rainfall through in the Coromandel coastline through the month of November, December, right, and even January. That helps in the sowing of the rice crops, variety of rice crops in the Coromandel coast or the Tamil Nadu coastline, the Boro variety in general, that is sown in these particular months, right, and they are harvested later on. So that is something which also influences the agricultural output of this region. Okay, now then comes the break in monsoon. What is the break in monsoon? So many of the times you would have experienced that during the monsoon months, after it has rained for continuously, let's say 4 to 5 days, after that, suddenly there is a gap in the rains. After that, suddenly there is no rainfall which is received for a long period of time. Now, that certain gap which is experienced is referred to as the break in monsoon. Now, why does that happen? It happens because, let's suppose, when you talk about the region of here, let's suppose we talk about this region. Now, here you have the monsoonal winds which are coming in. Now, they will cause heavy amount of rainfall in this area, right? Now, heavy amount of rainfall in this area means this region has become cooler. But let's suppose there is an extraordinary low pressure created somewhere here, very high low pressure, as in intense low pressure. So that means all these winds, they will get diverted towards that low pressure, right? So this region will experience a lack of rainfall for a prolonged duration of 5 to 7 days, isn't it? So that lack of rainfall which has been caused is because of, or what is referred to as, the break in monsoon. Similarly, let's suppose we consider one district A, another district B, or the distance between them, let's suppose, is 200, 300 kilometers. Let's suppose this is a distance of 300 kilometers. Now, for some time, A has been receiving very heavy amount of rainfall because of the low pressure. A has been receiving very significantly heavy amount of rainfall. Whereas when we talk about B, B is comparatively drier, right? Now, over the span of 2 to 3 days, A, because it has received very heavy amount of rainfall, A will become cooler, significantly and substantially cooler, right? So it will get converted into a kind of a comparative high pressure. What about the region of B? The region of B has not been receiving rainfall all this while. So it will become warmer in the process. 2 to 3 days of lack of rainfall, the region becomes very hot, very warm. So that is where it will develop a substantial low pressure, right? And this will Now, the next time, rain will happen here. So A will be deprived of rainfall for the next 5 to 7 days till B also receives rainfall and the A also heats up again to create that low pressure. So that gap which is created once the onset of monsoon has happened, that gap in the occurrence of rain is known as break in monsoon. So after rainy periods, if the rain fails to occur for 1 or more weeks, it is known as break in the monsoon, and they are very common due to different reasons. In northern India, rains are likely to fail if the rain bearing storms are not frequently along the ITCs. At the low pressure centers, they are not very commonly found. Then, many areas, they basically do not experience rains for a longer duration. Over the west coast, the dry spells are associated with the days when the winds blow parallel to the coastline. So, that is what is referred to as the break. Gaurav, northeast monsoon. Northeast monsoon, basically, it sets up immediately after the retreat of monsoon has been completed. That is when the northeast monsoon phenomena sets in. Here again, the principle is the same. That is, the ITCZ is the one which is going to attract the winds. But this time, the winds which get attracted, they move in a direction of northeast to southwest, right? So as they move from a direction of northeast to southwest, that is when they will basically be moving over the landmass. And because they are moving over the landmass, they won't have enough amount of moisture at all. So the land areas will not receive rainfall, but you will have certain areas, for example, the winds which will cross the portion of of Bay of Bengal, they will hit the Tamil Nadu coastline, the Coromandel coastline, and then they will bring rainfall in these areas. Eventual destination of these winds is basically the ITCZ. So at this point of time, even from the southern hemisphere, the winds, they will reach only up till the area of the ITCZ. So this monsoonal phenomena, why it is referred to as a northeast monsoon? Because as compared to earlier, if you observe here, the wind pattern, the wind direction has completely reversed. Earlier, the wind direction was southwest to northeast. Now the wind direction is northeast to southwest. So because the wind direction has completely reverted itself, hence northeast monsoon. It is different from the retreat. It is different from the withdrawal of the monsoon. Retreat or the withdrawal refers to the slow and steady disappearance of the low pressure systems or the ITCZ from the Indian subcontinent. Once it has completely withdrawn from Indian subcontinent, then the complete setting of northeast trades, they come into existence, and that is going to bring rains in the portion of Coromandel coastline known as northeast monsoon. Okay, is that understood, or is there a doubt which still exists? Do let me know. Gaurav, any doubts, any other doubts that you have, any portions that you have not understood? Do let me know. Okay, so I'm assuming no doubts. So then we move forward to the pre-monsoon showers. That is, even before the onset of monsoon, in certain areas such as Karnataka, Kerala, in certain areas such as West Bengal, Assam, you still receive some amount of rainfall. So the rainfall which is received in these areas prior to the onset of monsoon, just before the onset of the monsoon, that is what is referred to as pre-monsoon showers. Now, these pre-monsoon showers are initiated due to heavy convection, which is experienced in these regions due to heating. So, this is due to the localized heating in these areas and the localized convection which is initiated. Okay? Yes, Ganesh, that is true. So basically, you have that localized heating which is initiated, and that localized heating brings forward a localized convection in that area. So these regions receive rainfall. For example, and they are named differently in different parts of the country wherever they occur. For example, when we talk about mango shower, so mango shower, it is basically towards the end of the summer and the pre-monsoon showers in the region of Kerala and coastal Karnataka. This is because of localized convection due to localized convection. Okay. Now, this occurrence of rainfall, which happens, that brings forward, or that in a way creates a situation whereby it can lead to early ripening of mangoes in these areas, blossoming of coffee beans in certain areas, and hence they are named differently. In the region of Karnataka, where they help in early ripening of the mangoes, they are also referred to as mango showers. That is what we have as mango showers. Okay. Now, in the region of Assam, Bengal, there you have the convections, the localized convection, which are laden with moisture. So, late in the afternoons and early in the evenings, you have heavy thunderstorms in the form of very significant amount of cumulonimbus clouds getting created, dark cumulonimbus clouds, creating a kind of a thunder and lightning in the process, and bringing rainfall, which is beneficial for crops such as jute, which is produced in that area. Right. Now, thereby, it helps in the jute cultivation, but brings much required rainfall in that area. And that is what is referred to as Kal Baisakhi, because it happens in the month of Baisak, hence the name Kal Baisakhi. So, these are the dreaded evening thunderstorms. Their notorious nature can be understood from the nomenclature of Kal Baisakhi. These are useful for tea, jute, and rice cultivation. They are also referred to as Bardoli Sirha in the region of Assam. Okay. Uh, Gaurav, mango shower arrives in these areas in the month of late April and early May itself. Okay, because late May you have the onset of monsoon in many of the cases. So mango shower is late April, early May. Because I hope you are aware that in the southern part of the country, availability of mango is present much earlier as compared to the northern part of the country. In the northern part of the country, mangoes as a fruit are available much later because the ripening process takes time. But in the southern part of the country, these showers accelerate that process. Now, now we come to the winter months and the winter season. Now, winter season means the ITCZ now has completely and truly shifted to the south. So, in the winter season, you will have the ITCZ, which has completely shifted to the south. Okay. Now, let's suppose in this region, the ITCZ is here. Okay. Now, something very interesting happens during this point of time. During this process, something very interesting unfolds. For example, we do know that during the winters, we have all the pressure belts which will shift slightly to the south. So the subtropical high pressure belt will also shift slightly to the south, isn't it? Subtropical high pressure belt under normal condition is at 30 degrees. So here, when they shift south, they can come somewhere around the region of Tropic of Cancer. So let us assume the subtropical high pressure belt comes somewhere here. Assume. Now let us take a look to the west of India, in the region of Mediterranean. These are the months of November, December, January, February. That is the cold winter months. Look at the region of Mediterranean Sea. Now, in the region of Mediterranean Sea, here, if you observe, surrounded by landmass as it is, now water will be warmer in comparison to the land. Land will be very cold. Here you will have warmer waters, isn't it? So between the cold and the warm, can we observe a frontal formation? Surely we can. Can we observe a frontal depression getting created? Surely we can, as the fronts get deformed. And mind you, here the air will have heavy amount of moisture. So that latent heat of condensation, everything will come into place, and you will have a temperate or extra tropical cyclonic development happening in this area. It will bring rains in that area as well. But then you will have the presence of the westerlies. These westerlies, they will carry that depression, that entire disturbance. And these westerlies, they will carry them over. These will cross the region of Iran, Afghanistan to certain extent, and Pakistan. And then they will basically be these low pressure centers and these low pressure disturbances. They will be after that hitting the Indian coastline, or rather the Indian landmass. Now, when they hit the Indian landmass, they basically encounter the mighty mountains in the form of Himalayas. So in that situation, while you will receive substantial amount of rains in the region of Punjab, Haryana, Delhi, Western UP, sometimes even in the central portion of UP, Rajasthan, northern part, Bihar plains in certain extent, northern part of West Bengal, and sometimes even up till Assam. That is how far the rainfall will get distributed. But they will also hit the foothills of Himalayas, where they will bring rainfall. But within the Himalayas, they can bring snowfall as well. So when they will hit the Himalayas, they bring heavy snowfall, right? So that exaggerates the impact of winter season in northern India and also causes what is dreaded as the winter rains, right? Now, they are heavily laden with moisture, and these are traveling low pressure systems. So generally, they came into existence when over the Mediterranean you have warmer and colder air forming a front, coming together, right? Now, because they are moving from west and coming towards east, and it is a kind of a low pressure disturbance, that is why this phenomena is also known by the name of western disturbance. So western disturbance generally in November, December, January, February, March, and April. In November, you will experience this happening maybe 4 to 5 times, 3 to 4 times, not more than that, even lesser. December and January, when you will experience this happening individually, 6 to 7 times per month. Again, February, March, 3 to 4 times, and April, 2 to 3 times. That's it. That is what you observe here. That is what is the western disturbance. It is a traveling low pressure, traveling storm. And that exaggerates the impact of winter season, especially in the northern part of the country. This is the reason why northern part of country receives rainfall even in the month from November, December, January, February. This is the reason why sometimes when this low pressure reaches up till the area around Delhi, for example, and you have that low pressure causing so much amount of convection on the ground, Delhi during these winters sometimes also experiences hailstorm. Remember hailstorm? Something that we discussed last week. So basically, when this low pressure reaches the region around Delhi, a couple of years back, it reached even Jaipur. It can cause hailstorms in those areas, and people mistake it to be snowfall. They think about it that you have ice in the month of December, obviously it has got to be snowfall. Immediately on all the social media networks, you will have people clicking the pictures of it. You know what happened today? You had snowfall in Delhi. Delhi is like Srinagar now, and all the false information will start spreading. But this is the reason behind it. So it is helpful in winter crops, sowing of winter crops, such as wheat, mustard, pulses. They benefit at the time of the sowing. But then, when you have these conditions continuing till March, when you have these conditions continuing till the month of April, etc., that is when, at the time of harvesting, if still it rains, it can be disastrous. This time, however, something unique, unforeseen event happened this time. This time, this western disturbance was experienced as late as the month of May, June, July. That is why, I don't know how many of you remember this. This time, even in the month of May, Jammu Kashmir, Himachal Pradesh received heavy snowfall. Generally, the snow season in these states end by the time of March. But this time, even till 15th of May, the region of Jammu Kashmir, Himachal received heavy snowfall because the western disturbance kept on coming. It will keep on coming as long as there is a great difference in temperature between the Mediterranean and the European air mass. Mediterranean air mass obviously being warmer. As long as there's a difference, these will keep on coming. And that is the exact thing which happened even up till July. And that is when the low pressure system of the monsoon combined with the low pressure system of this traveling western disturbance, and the impact of it was so disastrous that Himachal Pradesh virtually was completely devastated in terms of the amount of destruction caused. Because when these two low pressure systems would combine, the amount of rainfall, the events of cloudbursts, each of those frequencies increase quite substantially. Okay. In the meanwhile, in the southern part of India, due to the northeast monsoon, the Coromandel coast will also receive rainfall. Okay. So, western disturbances are the low pressure systems which originate in the Mediterranean Sea and Western Asia and move into India along with the westerly flow and are hence known as western disturbances. They cause the much needed winter rains over the plains and snowfall in the mountains. Although the total amount of winter rainfall locally, which is known as Mahavat, is small, they are of immense importance for cultivation of crops such as mustard, wheat, and so on. Is these cold winds not stopped by the Hindu Kush mountains? No, they are not. So they move through that area, and the Hindu Kush mountains, they are not so significantly high enough. And in fact, if you take a look at it from here itself, they take a movement like this from as they cross over Pakistan. Okay. This is how these cyclonic disturbances travel all the way from the Mediterranean, and they keep on getting created and formed at the Mediterranean, and they keep on getting supplied. Right. So as long as you have extreme cold weather condition in Central Asia, in the northern portion of Asia, they keep on supplying that, and this disturbance keeps on getting created. Okay. That is something which happens during the winter. And this is the annual rainfall pattern in India. How is it that the rainfall is created, observed across different parts of the country? So you will observe that the regions on the western part of Western Ghats, very heavy amount of rainfall. Andaman Nicobar Islands, very heavy amount of rainfall. The northeastern portion, very heavy amount of rainfall. Right? But look at the leeward side, everywhere, dry. Right? So parts of Karnataka, parts of Maharashtra, Telangana, very dry. Parts of western Rajasthan, very dry. Why? Because the Aravalli ranges have a different alignment where the winds, they simply go parallel to it. Okay? So that is the rainfall pattern. Now let us take a look at the questions from this particular area. So which of the following correctly describe the phenomena of western disturbance? These are the aggravated monsoon winds blowing from west to east. They originate over the Mediterranean Sea and are carried to India by winds. Their effect can be felt mostly during the months of July to September. They can bring rains only over the hilly tracts of Himachal Pradesh. I expect all of you to get this correct. Correct. Abhishek, Shahid, Satyanarayan, Meera. Good. Utsav, correct. Gaurav, correct. Good. So here, basically, they originate over the Mediterranean Sea and are carried over to India by winds, westerly winds in general. Consider the following statements about the phenomena of El Nino and its effect on Indian monsoon. So, it occurs in the region of South Pacific and hence has no impact on Indian monsoon. It leads to increased rainfall over Indian subcontinent during the monsoon season. Its impact can be neutralized by Indian Ocean dipole and Madden-Julian oscillation. So, which of these are correct? Yes. Good. Satyanarayan, Utsav, correct. Meera, correct. Gaurav, correct. Abhishek, correct. Good. Shahid, good. Jaswant, correct. Usna, correct. Good. So the correct answer in this case will be C. So it occurs in the region of South Pacific and hence has no impact on Indian monsoon. Incorrect. It has an impact on Indian monsoon. It leads to increased rainfall over the Indian subcontinent during the monsoon season. La Nina does that, not El Nino. And its impact can be neutralized by IOD, positive IOD, and MGO conditions sometimes. So that is correct. So 3 only will be the correct answer. With reference to the retreating monsoon, consider the following statements. The Coromandel coast receives heavy rainfall as a result of this. It generally spans over a long duration from September to November. The movement of winds is from southeast to northwest. Which of the statements are correct? Anuranjan, correct. Good. Satyanarayan, correct. Meera, wrong. Shahid, Utsav, Satish, correct. Gaurav, correct. Good. So, Coromandel coast receives heavy rainfall because of this. It generally spans over a long duration from September to November, correct? After 17th of September is when the retreating monsoon is, the action of retreat happens, the process of withdrawal is initiated. Movement of winds is from southeast to northwest, incorrect. Movement of wind is northeast to southwest. So the third statement is incorrect. 1 and 2 are correct. So the correct answer is A. Okay. Now, after this, we will come forward to another module where we'll be discussing about the global climatic distribution. It is pretty theoretical out there. So we will try to cover it uh, in a quicker manner because most of it is written in the PPT itself. Wherever possible, wherever is a scope for some amount of explanation or concept, we will talk about that. But otherwise, we'll be generally restricting it because questions in the mains are not asked from here. 1 or 2 questions from the prelims are asked from here. So we'll be talking about from that perspective and we'll be discussing that. Before that, we take a break. So we take a break. It is a half an hour break. So we'll be back at around 6, 5:40. 5:40 is when we'll be back. Before that, leaderboard. Uh, okay. Satyanarayan, Ganesh, Shahid, Shiva, Govind, Shilpa, Niranjan, Nikhil, and Anuranjan. Very good. Beautiful. Good. So we meet again at 5:40, guys. And after that, we continue about the global climate.